We have talked about shorter period compounding and discounting, where we say that the rate of interest, which is the nominal rate of interest, generally given as annual rate of interest, is at times applied for more than once in a year. That is, we applied for 6 months or a quarter or a month or even for a shorter period. We have discussed that applying a rate more number of times in a year actually increases the effectiveness of the rate of interest. Now, if we are reducing the time period for which we are applying the rate of interest, we reach to a point where it becomes a continuous application of rate of interest. So we call it continuous compounding or continuous discounting. यानी हम अपने टाइम पीरियड जिसके बाद हम उस रेट को अप्लाई कर रहे हैं उसको छोटा करते हुए इतना छोटा कर दें, that is from 1 year we reduce it to half a year, or then we reduce it to, let's say, a quarter or a month or a week or a day or an hour or a minute or a second. And if we even shorter it, then we reach to what is called continuous compounding or discounting. Yes, theoretically and practically we have a formula and way to calculate the future value or the present value if the compounding or discounting are done continuously. If we keep on reducing the compounding or discounting period, then we reach to this minimum level which may not be described in time, that we are referring to a second or even a smaller part of a second, but this is what is called continuously discounting or compounding an amount. This certainly increases the effectiveness of rate of interest to its maximum. यानी हमने ये बात की थी कि जब हम कंपाउंडिंग को शॉर्टर पीरियड के लिए करते हैं तो उससे उसकी इफेक्टिवनेस बढ़ जाती है और इस तरीके से हमारे पास ज़्यादा फ्यूचर वैल्यू आती है. अगर हम इस टाइम पीरियड को इतना शॉर्ट कर दें कि ये कंटिन्यूस कंपाउंडिंग हो जाए तो उस केस में जो इफेक्टिवनेस ऑफ द इंटरेस्ट रेट है दैट विल बी इंक्रीज्ड टू इट्स मैक्सिमम. नाउ लेट्स हैव अ लुक at the formula of continuous compounding and discounting. This is the formula where we see that the future value is the present value multiplied by E. E is a constant and its power is taken as R multiplied by N, where R is the same rate of interest and N is the number of compounding periods that we have. Now, in this case, this E, which is an exponential constant, has a constant value. We know that constant and variable are the two terms that we commonly use. Variable वो चीज़ है जिसकी value vary या change हो सकती है. For example, height, weight, length, ये variables हैं. लेकिन constant वो चीज़ है कि जिसकी value एक ही होती है और वो वही रहती है. For example, pi is a constant and exponential constant E is also a constant. Any integer 2, 4, 5, 10 is also a constant because it has a definite value. So the value of this exponential constant is 2.718. So what we do is we multiply the present value with this exponential constant and take its power as a product of the rate of interest and the number of years or the compounding periods, and what do we get is the future value. Similarly, the same formula can be applied by dividing the future value with this factor. यानी अगर हम this exponential constant raised to the power r into n से अगर future value को divide कर दें तो हमारे पास present value आ सकती है. Which means that in case of continuous compounding or continuous discounting, we can calculate the present and future values. Let's have a look at the calculations. With the help of this example, we see that if 1000 rupees are continuously compounded at the rate of 10% per annum for 2 years, what will be the future value? So in the formula, we take the value which is given to us today, that is 1000 rupees, and we multiply it by the value of the constant, which is 2.718. This value will always be the same in all the applications of continuous compounding or discounting. And we'll take the power as 10%, which will be shown as 0.1. And because it is done for 2 years, so we take the power equal to 2. Now the answer for this is 1221.38. And this is the maximum value that we'll get if we calculate with shorter period compounding the future values. यानी अगर हम biannual compounding करें तो उससे quarterly compounding की value ज़्यादा आएगी. अगर हम monthly compounding करें तो उससे हमारी value मज़ीद बढ़ जाएगी. इसी तरह अगर हम daily compounding करें या hourly compounding करें तो हमारी value बढ़ती चली जाएगी. And with continuous compounding, we'll get the maximum value, and this is the value that we will get. Similarly, if we carry forward the example and try to calculate the present value using continuous discounting, you can see that the formula is the same, except that now the future value is divided by the exponential constant with a power equal to the rate of interest multiplied by the number of years. We have got number of years equal to 2 and the rate of interest is 10%. So what we'll do is, if this 1000 is now taken as the future value, so we'll divide this amount of 1000 by 2.718, which is the value of the constant raised to the power minus 0.1 into 2. So if we want to calculate the value for 3 years, 4 years, 5 years, and at 10, 20, 30, 15, 18, any percent of interest, we can make the changes in the power and we can calculate the value. So we have got a value equal to 818.75, which is the present value using continuous discounting. So in this way, under the discussion of shorter period compounding, this is the culmination of the shorter period compounding, where the periods are reduced to such a minimum level that it becomes a continuous compounding or a continuous discounting case.